So you're trying to figure out the career path for computer science or software development, but you're not quite sure what each one entails. In this video, we'll learn more. Stick around to find out. Whether you just finished a computer science degree or you're simply looking to figure out what avenues there are in software development, this video will be for you. We're going to talk about the possible career choices. As you can see, that's an extensive list, but I narrowed it down to 9 of some of the most popular ones, and we'll talk about those. We'll talk about the job responsibilities at a high level, the frameworks, the tooling. Again, this isn't going to be perfect as each career has a lot of nuances. And since we're keeping it high level, we're not going to be able to dive into all of the possible frameworks and toolkits. But instead, we'll just focus on it very briefly so you could at least have a high level understanding going forward when you're picking your jobs in the future. Hopefully this video just gets you thinking about the possible jobs and get your foot in the door in order to become a better developer or figure out something that you may enjoy and be passionate about in the future. So let's dive right into the list. Okay, so in no particular order, number 1 is a software engineer. A software engineer is the jack of all trades. They don't necessarily have defined frameworks and programming languages. Really what they are responsible for is helping implement architecture designs based on customer needs. So really focusing on requirements, non-functional requirements, functional requirements, and trying to design an architecture based around those requirements in order to produce the best result for a customer's need. So a customer will come to a software engineer with a problem. The software engineer will then design a solution based around the problem, implement that change, and then hopefully have some kind of product for the customer. Now, as you could tell, software engineers can fall under the domain of all of the professions that we're discussing further, but a lot of the time, the thing that makes a software engineer really specific is the fact that they're able to derive a lot of requirements and derive a lot of information from a customer in order to produce really solid architecture, design, and implementation. Number 2 is the web developer. The web developer is responsible for 2 things. In this case, I'm going to refer a web developer as a full stack engineer. A full stack engineer is someone that focuses on the back end and the front end. You could have engineering professions that are just focusing on the front end or the back end, but in this case, when I say web development, I'm referring to both. The back end engineer, you can imagine the analogy of a car. We have the engine of the car, and then the front end engineer will focus on the appearance and interaction with the car. But in a website, and more specifically, the front-end engineer will focus on the user interface, the user experience, making sure that all of the platforms that the customer is interacting with, that the user is interacting with, is smooth, easy to understand, and really intuitive. While the back-end engineer will focus on how the user is able to log in, authenticate the user, how the databases store information respective to that user's account. All of that is back-end engineering. Some of the respective frameworks for that might be Bootstrap, Express, Node, Ruby on Rails. All of this is some of the frameworks that are used in web development, and some of the respective languages might be HTML, CSS, JavaScript, Python. All of this could be used within web development. The mobile developer is very similar to that of the web developer. There's both the front end and the back end for mobile development. But again, when I refer to mobile development, that the profession is competent in both front end and back end. In this case, the most common thing you can imagine is a mobile developer trying to build applications for a mobile device that doesn't necessarily have to be a phone. Anything with mobile operating systems like iOS or Android. Some of the frameworks and tools would include something like React, Flutter, Xamarin, and the languages corresponding to that might be Java or C, C#, respective for Android development, while something like Swift might be really good for iOS development. Number 4 is the AI ML engineer. This focuses on solving a very specific problem with a lot of information and data. And the best way I could really put this into words is through an example. Let's look at something like Netflix. When you open up your Netflix account, how do you have movie recommendations based on your preferred likes and needs? That's going into a model based on a conglomerate of information found throughout Netflix. Based on your user inputs, it tests against that model in order to give you some kind of recommended output. Other things like large language models within ChatGPT are a great example of AI ML engineering. But again, the purpose of an AI ML engineer is to be able to have an automated way to process data very efficiently within some kind of model, take that data, process it, test it against testing data, and give you some kind of automated solution to a very niche problem. Some of the frameworks for this might be something like TensorFlow, Keras, and PyTorch. The majority of the languages are going to be in Python. There is a little bit of C in that, but most of it is in Python and far and few are in C. The next one is data scientist or data science. Data science is very similar to that of AI ML engineers, but unlike AI ML engineers that are taking information and training models to do a specific task, data scientists try to produce some kind of understandable data from a large data set that might not be human readable. So that'll be parsing information, visualizing information, and making it usable to a consumer in some way. Some of the frameworks would include something like Pandas or NumPy, and the most common programming languages would be Python and R. Cybersecurity engineers are really responsible for finding security vulnerabilities and bugs within a code base. Oftentimes, a team will have a dedicated cybersecurity team that is able to develop tools that scan a developer's code base to determine if they have vulnerabilities or code smells, anything that could cause an external entity or a hacker to have your product or development platform behave differently than it's meant to be. A cybersecurity engineer will look over all of that and try to make the most secure program that you can based on an individual's developed system. A lot of these are really automated with things like SAS, which is static application security testing. But the cybersecurity engineer will look over a code base, review it, and try to find potential vulnerabilities that someone could expose and resolve those vulnerabilities. So some of the tooling and frameworks for cybersecurity engineers might be something like Metasploit, CI/CD, whether that's through GitHub Actions or GitLab pipelines, things like Wireshark for networking traffic, and the languages are undefined as cybersecurity can cover almost any domain, whether that's mobile development, web development, AI, anything could utilize cybersecurity and vulnerability detection. The next one is DevSecOps, which is development, security, and operations. Now, you could remove the security part and just have a dedicated cybersecurity engineer, and it'll just be called DevOps. But what they really focus on is automating deployments and automating the ability to have production level applications. What does this mean? A lot of the time, developers will program code bases and test it all locally, test it against their own environments, but there has to be an automated fashion to deploy that to production. A DevOps engineer automates every single process of the production deployment. They also make sure that the operations of the deployment behave as expected, and anytime that there's an issue, a DevOps engineer will be trying to fix it. That's where most often patches and semantic versioning comes in, where a DevOps engineer could deploy hotfixes in an automated or easy fashion. Some of the frameworks for DevOps engineers and toolkits for DevOps engineers would be something like CI/CD with GitHub Actions or GitLab pipelines, Kubernetes, Docker, Ansible, Terraform. All of these are very DevSecOps oriented frameworks, and a lot of the languages will be dependent on the application you're actually running against. The next profession is the cloud solutions architect or the cloud engineer. This is somebody that's really proficient in cloud services like Azure, Google Cloud, AWS, something for either monolith or distributed systems. This allows an individual to deploy an application to the cloud and not have it run on a dedicated server. This has been really popular the past decade as compared to something like the early 2000s where it would be running on dedicated servers. Cloud solutions are really just meant to optimize applications and be able to deploy them to cloud-based platforms. That way you don't need a dedicated server running, which is a lot of overhead and cost. There's a lot of nuances with how cloud solutions actually works. So you often need a cloud architect in order to do that. Things like load balancing, more specific things like Elastic Beanstalk or EC2 within AWS. But all of these are just fancy words for deploying a code base or an application to a virtualized environment within the cloud that users can then access. Some of the platforms you might use are Google Cloud, as mentioned earlier, AWS, Azure. A lot of the languages are just dependent on the APIs that the cloud service uses, and most APIs support a lot of languages, whether that's JavaScript or Python or Java. Things like AWS CloudFormation or Google Cloud Console, all of those support various APIs in various languages. Finally, I wanted to include something like game developer, which is a little less of the traditional computer science, software engineering, software developer route, and focuses more on actually developing the games. Some of the respective frameworks might be something like Unity or Unreal Engine. A lot of them work with programming languages like C#. So in conclusion, this video hopefully helps you understand some of the possible avenues you could take as a software developer. Again, this is a very high-level video, and I did not go into some of the more nuanced and details of each profession, but hopefully it just gets your foot in the door in understanding what the profession is responsible for and some of the frameworks and tooling that are correlated to that profession. If you like this video, leave a comment down below, like and subscribe. I'll catch you on the next one. Thank you.